Hi, welcome back. We are talking about 3.6 and 3.7, that is total fertility rate and age structure diagrams. Our learning objectives for today are to explain age structure diagrams and explain factors that affect total fertility rate in human populations. So first, we need to define total fertility rate. Oftentimes, we just call this TFR. TFR is the average amount of offspring a woman within her childbearing years will have within her lifetime. We identified childbearing years as 14 to 45. This is basically the onset of puberty to the onset of menopause. So for this class, that's the age range that we'll accept. Total fertility rate largely is usually dependent on whether you live in a developed or a developing country. A developed country, by the way, is generally a country that has relatively high levels of industrialization and income. In most developed countries, we see a TFR of about 2 children per female. This is also called replacement level fertility, which we'll talk about here in a minute. In developing countries, we tend to see a much higher TFR. So a country that has lower levels of industrialization and income, which also comes with other associations, they generally have a TFR that is greater than 2.1 offspring. And it will vary from country to country depending on where they're at within their development process. And we'll talk about factors that can also contribute to varying levels of total fertility rate. Now, I just mentioned this concept, replacement level fertility. Replacement level fertility, or RLF, is the total fertility rate required to offset deaths in a population and keep the population stable. So this is how many offspring we need to have, or each female needs to have, in order to replace the population and keep it at a stable point rather than contribute to a declining population. So this is what this is the minimum number of offspring an individual needs to have in order to maintain the population. In a developing country, that number is still 2.1. Essentially, you are replacing the mother and the father of the child if you have 2 offspring. So the mom and dad are one life. As the mom and dad die, then those 2 children replace them within the population. That's replacement level fertility in a developed country. In a developing country, that replacement level fertility number may be higher due to higher infant mortality rate. So if your offspring is not surviving, if your infant child is not surviving, your replacement level fertility may be higher. You may need to have more offspring to offset the fact that you've lost offspring in the process. And again, that number will vary based on the country. Now, another one that we'll look at is something called IMR. I know there's a lot of these, but this is infant mortality rate. So infant mortality is also recorded as a crude number. So remember, crude is per 1,000. So infant mortality rate is the number of deaths of children under 1 year of age per 1,000 in a population. So it's how many infants that we're losing per 1,000. And of course, in a developing country, we tend to see a much higher infant mortality rate, and this is generally due to less access to healthcare, sanitary living conditions, food, water, etc. If you have a higher infant mortality rate, you generally have a higher total fertility rate. The higher total fertility rate means that you're going to have more offspring. This is replacement level offspring. Now, we differentiate infants from children based on being over 1 year of age. So if you're between the ages of 1 and 5, you are considered a child, and we would also record a child mortality rate. So you could call that a CMR. That is also recorded as a crude number, so per 1,000, and could also impact your replacement level fertility. So perhaps people will have more children if they are losing, they'll have more offspring if they are losing a child as well. So what are some things that contribute to infant mortality rates? Again, access to clean water, access to healthcare like hospitals, vaccines, supplements, a reliable food and water supply. All of those things can contribute to early death. So remember, offspring really need quite a bit, human offspring need quite a bit of care very early on in life. Whenever you hear about diseases that are spreading, you often hear about You often hear about populations that are the most susceptible, which are the elderly and the young. This is due to compromised immune systems, weakened weakened body function. And so infant mortality rate in countries that don't have basic sanitation or access to healthcare, those parties are far more susceptible to death. Here's just a visual for you. So looking at global total fertility rate versus global infant mortality rate. So just because we live in the US, you can see our global total fertility rate is somewhere in this range. Looks like we're in the 1 to 2 range, which we kind of already knew. This is 2019 data, by the way, for both of these. And then you can see some other countries in Africa. Obviously, we see some that have much, much higher total fertility rates, and this is largely due to either needing replacement level fertility or not having access to contraceptive methods. So just having a lot of offspring because there isn't a way to prevent pregnancy. And then global infant mortality rate. So you can see in the US, we are in the less than 10. It looks like we're 6.6 per 1,000 births. So again, it's a crude rate for infant mortality rate. Global rates are quite a bit higher. So our average is 49, but you can see again in some countries or some continents, I guess, like in Africa, parts of Africa, we see a much higher infant mortality rate. And again, that would be due to just access to water, healthcare, etc. So what are some factors that contribute to higher or lower levels of total fertility rate? Generally, it has to do with affluence and how much industrialization is occurring in that country. More affluence and more industrialization leads to more education access for women, more economic opportunity for women, higher access to family planning, education, and contraceptives, so preventative measures to take to not get pregnant. Later ages of first pregnancy, so you're having children much later in life, which means you have a smaller window to have children in, which means you can have less children within that window. And then additionally, you probably don't need to have children to provide income for labor. So you don't need more labor within your family to provide income to support the rest of your family. That's another reason why people might have more children. Other things that can affect total fertility rate are government policies. So you guys have probably heard that China had that one child, it's now 2-child policy, where they were limiting the amount of children or offspring that people can have. That is probably the most widely known example. There are other examples of countries or governments sort of regulating fertility, either through forced or voluntary sterilization, so preventing people from having children at all. Tax incentives to have fewer children. These are all ways that we would kind of consider to decrease population sizes, providing some sort of financial incentive for women to either go into the workforce or go into education, go get an education to try to incentivize them to have less children. It could also go the other way. If a population is declining, the government may incentivize people to have children, like if they're worried about the workforce. So they may offer tax breaks, like if you have a child this year, we'll give you a break on your taxes, or we'll pay for them to go to college, or the other way around. So it kind of depends on what the country is, what the country's population growth rate status is at, and what they're most concerned about. If they're concerned about overpopulation of their country, then they may offer some sort of incentive to have less children, or the other way around if they want to have more children. One more thing that can affect, that's a pretty big thing that can affect relative population, total fertility rates and relative population sizes, are aging and disease. Disease is a pretty important regulator of human populations. So this is what ends up killing a lot of people. The World Health Organization says that microbes are the second biggest killer nationwide after heart disease. So a lot of people die from disease. Most common ones, not necessarily in the US, but worldwide, are TB, malaria, and HIV/AIDS. And HIV/AIDS is responsible for the most deaths annually. Again, we're talking about in the world, not in the United States. Most of these cases are in Southern Africa. Now, just to also give you some perspective on average life expectancy. So the U.S. has an average life expectancy of about 76, but there are countries that exceed us by almost 10 years. Hong Kong, for instance, has an average life expectancy of about 85 and a half years old. Japan also is about 85 years old, so quite a few years on the U.S. But the U.S. is relatively high compared to some places in Africa, which are really low. Like I think one of the lowest is the Central African Republic, which has an average lifespan of about 53 years. So the last thing we need to talk about are age structure diagrams, or what we call population pyramids. So an age structure diagram can be represented in a couple ways, but it's some type of visual representation of the number of individuals within specific cohorts. And I'll explain what a cohort is and how we define those. And one visual that we use are population pyramids, and I'm going to show you what those look like. And depending on the shape of a population pyramid tells you a lot about the relative population size, current population size, and then what that population momentum might look like. So what it will look like after generations and generations of time. So first, what are age cohorts? So age cohorts are going to be groups of similarly aged individuals, and we break them up into three categories. So there's the age 0 to 14. These are going to be the blue bars in here. These are the pre-productive population, meaning they are not able to produce any offspring. This would be your pre-puberty population. Then you have your next cohort, which is 15 to 44. These are going to be your reproductive aged individuals. So these are individuals that have the ability to have offspring. And then you've got your 45 plus, which are post-reproductive. It doesn't mean they don't have the ability to have offspring, but are far less likely to have offspring. So we call this post-reproductive. Now within here, there are, of course, these are just age cohorts, of course, that are associated with reproduction, because that's sort of what we're talking about. But you could break them up into other categories as well. 15 to 65, maybe your working class. You've got post-working class, pre-working class. So you could have other cohorts listed within, but generally when we're looking at these age pyramids, we're looking at where the population size is going to be moving. So we're most concerned with reproduction status. Now, depending on how big each of these cohorts are, sort of can be very telling about what a population may look like over time. So if you look at this first pyramid, for instance, we have a really large base to our pyramid. This is like a really dramatic pyramid shape. So our 0 to 14 cohort is really large. This is very indicative of a fast growth rate, which means these members of the population will eventually be these members of the population, and they're all going to have offspring. So the base of the pyramid will continue to get larger and larger and larger. So this would be a growing population, a rapidly growing population. Now here we see the yellow band and the blue band pretty similar to each other. This one definitely has a slightly larger base than this one. This one is indicative of a growing population, but much more slowly. So because this is larger, you are going to see a larger reproductive age at some point, which means they could have offspring, but it's unlikely that it's ever going to be really drastic. And then in this one, you're seeing a stable population. This is basically replacement level fertility. The population isn't growing really very much. It's remaining pretty stable. These individuals will replace these individuals, and likely birth trends will remain the same unless maybe something happens within that country. And then on this last one, it's where you have the top portion of the pyramid outweighing the bottom portion. You have more of an elderly population than you do a young population. So as a result, the population is declining. It looks like these individuals are having even less and less and less children. So this is indicative of a population decline. So you can really define these as certain shapes and then define trends within the country, which is kind of what we just said. You have the really extreme pyramid shape, that should tell you rapid growth is happening. If you have the less extreme pyramid shape, but still a bigger base, that's going to be slow/stable growth. This is kind of what we're seeing in the US. If we have the house shape, this is stable population growth. The population sizes aren't changing at all. And then we have a declining population if the base of the pyramid is smaller than the top, an upside down pyramid, if you will. And then the only reason I have this one, these are really similar. You have the pyramid shape. This is rapidly growing. You've got the column shape. This is relatively stable. This one shows declining population, and then this is sort of a new one. This one shows like really random lines that don't really show any kind of trend. Generally, if you see something that's super random like this, you're looking at a country that has undergone population control measures of some kind. Like you've had decades of time where population control measures were implemented, decades where they weren't, etc., and you're seeing sort of the drastic shift within that. So as you're going to get AP test questions, they'll ask you to evaluate the status of pyramids. They'll ask you to determine what they think the pyramid is telling you, etc. And you'll need to know some of these basic trends. Okay, I think that's it. Let me know if you guys have questions. If not, I will see you in class. Thanks.